Is Mr. Strong here yet?
I have no idea.
Alright, well if he comes in while I'm gone, tell him I'll be right back.
Okay.
All right. So, sorry I got locked out of the room. And I come in and all the monitors are off. I can't see you. I don't even know what's going on, but Anyway, I'm glad you're here. Tobias, thanks for dressing up for class, adding a little class to the class. So that's nice. All right, well, let's go ahead. So what's going on, Tobias? You going somewhere today, or?
No, I just got done with my senior presentation.
Oh, yeah? So what was it on?
Surgeon, being a surgeon.
Being a surgeon? I thought for sure it would be on how math changed my life or something like that.
No.
No? Oh, well. Well, surgeons have to know how to use math too, so that's all good. It's all good. All right. Well, anyway. Okay. All right. Well, let's get this thing in. So today, let's see, we're going to do 11.5, where we're going to start. It is a very short section, so we may get into 11.6 as well. We'll just see how that goes. Okay. All right, so let's see. All right, so we're talking about areas and lengths in polar coordinates. But before we get started, does anyone have any questions on anything? Okay. All right, so here we go. When we're doing an area of a region in polar coordinates, usually it's like a fan-shaped region because you're going from one angle to another angle, and then like the radii in that. Okay, and so you'll have a function of a polar equation, r equals, and then a function of theta. And so the formula is the area of that wedge, that pizza slice, is the area from A to B, and A and B are the angles, okay? And then it's 1/2 of, so whatever the function is in terms of r, 1/2 r squared d theta. So that's the formula for it, okay? So it says find the area of the region in the xy plane enclosed by the cardioid, r equals 2 times 1 plus cosine theta. All right, so if you go all the way around the circle, that would be from 0 to 2 pi. And so usually those are going to be the limits of integration, but sometimes it's helpful to actually graph it and see that maybe you can use symmetry or something like that. But I'm going to for ease of this, I'm going to just go from 0 to 2 pi, and then it's 1/2 of whatever r is squared. Okay. Now, so depending on how good you are at putting it in the calculator, you might just put it in right like it is right now. Now, but you're going to want to be in radian mode, but you can use x's for thetas or whatever. You don't, when you're putting this in the calculator, you don't necessarily have to be in polar mode, but you do have to be in radian mode because these are angles in radians, okay? Now, so you can put it in just like that, or if you want to simplify it out, then you can certainly do that. So here you square out the 1 plus cosine theta, so that would be 1 plus 2 cosine theta plus cosine squared theta, then you square out the 2 and get 4. And the 4 can cancel with the 1/2. And so then you get 2. And so then I pull that out front. Okay? Now, so then the integral of 1, d theta is just theta. The integral of 2 cosine theta is 2 sine theta. And then the integral of cosine squared theta, I looked that up and got that. And then you plug in the 2 pi minus when you plug in 0. And, well, actually, it looks like I simplified here first, combining like terms, distributing the 2. Then once I plug in, everything goes to 0 except the initial 6 pi. And so that's the answer. Now, of course, if you do it in your calculator, it's going to give you the decimal equivalency of that. But really, for some of these, they can get pretty tricky pretty quickly. And so some of them, the integration might even be pretty messy. Yeah, and like I said, integrating cosine squared is not something that you do every day. So like I said, I looked that one up just to be able to do it by hand. But so really at this point, from the very beginning, once you set it up, you can put it in the calculator if you want. Okay? All right, so let's have you try the first practice problem. Right there. All right, Tobias, what do you have?
So I put it in my calculator, and if I put it in right, then I got 1.285.
Good job. That's it. Okay. Yeah, 1.285. That's all we need. We don't need that. So the integral from pi fourths to pi halves of 1/2, and then probably the most common mistake that people make when they set this up is that where the 2 goes with the sine theta, and so both of them are squared. Okay, and then the d theta. All right, any questions on that? All right. So now let's say we have the area between polar curves. All right, so now in addition to having the angles be our limits of integration, we also can have two different radii. Okay? And so what you do is you want to look at the graph of this, and then let's say if R2 is your outer radius and R1 is the inner radius, then it's the integral from A to B of 1/2, and then it's the outer radius squared minus the inner radius squared. Okay? So, for this one, it says find the area of the region that lies inside the circle, R equals 1, and outside the cardioid, R equals 1 minus cosine theta. Okay? So here's 1 minus cosine theta, right here, this cardioid, and then here's R equals 1. Okay, so if we want to find the area in between there. Now, here's the thing, is that what I've noticed in doing these problems is sometimes weird stuff happens as you're going from 0 to 2 pi. Like you get negative r's and weird stuff. So I can set it up to go from negative pi halves to pi halves, because that's where this area is. But you're actually better off, although you get the same answer, if you go from 0 to pi halves, so just this top half, and then multiply that area by 2. As you can tell by symmetry, it's the same area. So you just go from 0 to pi halves, okay? You multiply by 2, and then when you bring the 1/2 out front, that's going to cancel anyway. And so then it's 1, the outer radius, which is 1 squared, minus 1 minus cosine squared. And so then if we just simplify, and we could put it in like this, or just simplifying it a little bit. 1 squared is 1 minus, and then square that out, 1 minus 2 cosine theta plus cosine squared. And so then these will cancel. Integral from 0 to pi halves. 1 minus 1, that's going to cancel. Minus a negative 2 will become plus 2 cosine theta minus cosine squared theta d theta. And so that's what I would put into the calculator at that point. Now, once again, you can keep going and integrate by hand. But if you do it, it takes a few steps, but you end up getting 2 minus pi fourths, or 1.215. Okay, is your answer. Okay, now the practice 2 on your paper, I would like you to change a little bit, because I don't like how that one turned out. So let's change it a little bit. Okay. Okay. So let's find the area of the region shared by okay, so let's just say R equals 2 times 1 plus cosine theta, and R equals 2. Let's see how that looks. Okay. So this is... Okay, so it says you want the area of the region that's shared by those. So what you want is, whoops. So this part in the middle. So you want this area right here. Okay, now the formula I gave you, though, gives you the area between curves. So if I, so let me just tell you that it's like the formula I gave you where this is the outer one and this is the inner one. It's like I could get that area right there in green, using the red as the outer curve and the blue as the inner curve. So how can I get the highlighted yellow area?
If you added them instead of subtracting them, and then you subtract off both of the outside curves.
Okay. So what area am I going to find? What integral am I going to use? So anybody, any of you guys chime in if you have an idea what to do here. So Weston, what do you think we should use as our integral?
Well, the way I was explaining it would be pretty long.
Okay.
So I don't know if that's right.
All right. Well, how about this? What if I found this area and then subtracted it from pi r squared, the circle? Does that make sense?
Yeah.
So the radius here is 2. So the area of the circle is going to be 4 pi. So if I took 4 pi minus this area, then I would get the area that I want. Okay? So then the question is how do I find this green area then? Well, now I use the formula that I had. And so it's going to be 1/2. The big R squared is the red. The little r squared is the blue. Okay? So what would be my limits of integration? What would be the limits of integration where think about what would be the angle that I would use to intersect both the blue and the red? See, in quadrant 1, from 0 to pi halves, I would be getting this area out here. I don't want that. I don't need this area. Because of the way I'm doing it, I just want this over here. So what I want to do is I want to integrate from pi halves to 3 pi halves. Or actually, because of symmetry, if I just found that area right there in green and then doubled it, I would get this. So instead of going from pi halves to 3 pi halves, I'm going to just go from pi halves to pi. Okay, and then 1/2 times. Okay, so the big R is which one? What's the function for the big R?
2 times 1 plus cosine theta.
No, that's the blue. That's in here. See, the big R here is going to be just 2. Because it's the circle. So imagine, see, I'm not showing this well. But so you imagine, if you're, sending out a ray from here to here, see, it's going to hit the blue and the red. Well, the red is the outside radius, and so it's that minus the inside. Okay? And so as you go through the angle, see, it's the red is the outside, the blue is on the inside. Okay? So the red is the 2, R equals 2. So it's going to be 2 squared minus the inside radius, which is the blue, 2 times 1 plus cosine theta squared. And then d theta. All right, so see if you can put that in your calculator and get an answer. All right, anybody get it?
I got 2.850.
2, and is that with 4 pi minus the integral?
Yeah.
Okay. So 2.850.
Yeah.
All right. Did anybody else get that? I would love to have confirmation. Not that I don't trust you, Weston, but Tobias or Jada, did you get it?
I didn't, but I think I see somewhere I messed up on the calculator, so hold on.
Okay. Oh wait, did I not multiply by 2? So from pi halves to pi, yeah, I forgot to multiply by 2 here. Sorry, Weston.
Yeah, I forgot the 1/2 too, so.
Oh, so our mistakes canceled each other?
Yeah.
Oh, sweet. All right. Okay, I'll go with that. So from pi halves to pi, Okay, and then I've got 2 squared minus parentheses 2 parentheses 1 plus cosine theta close the 1 plus cosine theta, close the 2 squared and close the integrand, and then d theta. Seems like there's too many parentheses there, but let's just see. Okay, so I got 7.708. Anybody
That's
else
what
get that?
Yeah, that's what I got when I
Okay.
redid it.
All right, good enough. All right, so Jada, how about you? Did you get that, or do you see where you might have messed up?
No, I got the 7.7. I just didn't know. I thought I was wrong.
Okay. Have more confidence. You know, be willing to say, Mr. Strong, you are wrong, I am right. And let me show you where you messed up, Mr. Strong. You need to be able to do that. All right, so Tobias, did you get it right, or did you see where you messed up?
Yeah, I see where I messed up.
Okay. Was it with the parentheses?
Yeah, I missed a parentheses when I squared it, I think, so I squared it wrong.
Yeah, that's really. I was nervous when I was doing it, thinking that it was just seemed like it was too many. But anyway, okay, all right. Well, let's go on to the last part here. All right, so the length of a polar curve. Now we've actually done lengths of curves that were functions of x. And we've actually done lengths of curves that were parametric. This is the third formula for length of curve. This is the polar curve. So it says if r is equal to a function of theta, it's has a continuous first derivative for theta in between a and b. And if the point r theta traces the curve exactly once as theta runs from a to b, then the length of the curve is L equals the integral from a to b of the square root of the function squared, r squared, plus its derivative squared, d theta. And that's actually how it worked in function notation. It was f of x, or y plus y prime squared. So it's the same idea. The square root of the function plus its derivative squared. All right, now, so it says find the length of the cardioid. So here, if you integrate all the way around, then it will trace at one time. Okay? So you can have your limits of integration go from 0 to 2 pi. Or if you want to just go from like 0 to pi, because of symmetry, you can double it. Okay? So now, the first thing I do in setting it up is take the derivative. So I'll say dr d theta, the derivative of 1 minus cosine theta is sine theta. All right? Then, again, you can integrate it from 0 to 2 pi of r squared plus dr d theta squared. All right? Now, on these, because you end up with sine squared plus cosine squared, a lot of these, I will definitely simplify this. So if I FOIL this out, I get 1 minus 2 cosine theta plus cosine squared. And then I have plus sine squared, so this will become 1. And so then this becomes 2 minus 2 cosine theta, d theta. And so then I would put it in the calculator like this, or integrate from 0 to pi and multiply by 2. Okay, so you could enter in this one from 0 to pi, multiply by 2, and then radical 2 minus 2 cosine theta d theta. So I would enter it in one of these ways. Now, you can actually still work it out, but at this point I would just, you know how to do the calculator, so do it. Okay? All right, so let's go ahead and have you try that last practice problem here. See if you can set it up. Whoops. So find the length of the cardioid, 1 plus cosine theta. All right, so Tobias, when you've got it.
I got 8.
Isn't that weird that it would be an exact out value? I mean, look at this crazy looking graph and the crazy different looking functions and the derivatives, and you do it and you get 8. Okay? And it's not even a lemniscate. That was a little polar humor there for you. But anyway. Okay? Good job. Jada, do you have a question on that?
No, I'm good.
All right. Weston? Did you get it?
So, how did you get rid of the negative sign?
And with the sign? Because when you square it, it becomes positive.
Okay.
It's negative sign times negative sign is positive sign squared.
Okay.
And then cosine squared plus sine squared becomes 1. So that 1 becomes a 2. Okay? Now, you could have actually plugged it in here up at this point, and you still should have got 8. Okay? And you could have also integrated from 0 to 2 pi, and you still would have got 8. Okay? All right, anything else? All right, I don't see any point in starting the next lesson, so we've got less than 10 minutes. So let's just go ahead and call it, and we'll pick it up. We'll go to 11:06. Oh, one thing I've decided to do is because, we're still covering new material this last, right up until the end. In chapter 11, I'm not going to do a quiz per section. I'm going to do one quiz on the first half of the chapter and one quiz on the last half of the chapter, just so you don't have so much, okay? So the first quiz I will post probably tomorrow morning, and it'll be on 11:1 through 11:3, I think, okay? All right. Well, we'll see you guys. Have a great day. Thanks for working hard. We'll see you tomorrow.